Assalamualaikum. Hello everybody. Thank you for watching this video. We will continue these chapters. Chapter 3, OSI 7 layer principles. So in this video we will describe a little bit detail of those 7 layer OSI model. Okay, so we have discussed before. There are 7 layers in OSI model, which consists of physical, data link, network, transport, session, presentation, and application. Okay. The main idea, the layers are realized by combination of the operating system. Operating system. The applications, for instance, a browser. Okay. Network protocols such as TCP/IP, and the software and hardware that actually place a physical signal onto a transmission line, which involve of an NIC. NIC is a network NIC is the network card. Hold on, yeah. Let me see. Network interface card, or network interface controller. Okay, NIC. Network interface card or network interface controller. Okay, modem and so on. Don't confuse TCP/IP, the stack model, with layers protocol TCP/IP, layer 4, and IP, layer 3. Okay. So TCP/IP is the model. Then the layer is different, with different thing. Okay. OSI, network or computer. The transport layer can be viewed as the division between the computer and the network. So the transport is the layer number 4 in OSI model, can be seen as the division, the border, okay, the border between the computer, between the hardware, the computer, and the network. The lowest 3 layers in the OSI model, the physical, data link, and network. So this physical, just now, number 1. This is data link number 2, and network number 3. Okay. The lowest 3 layers, physical, data link, and network, deal with best effort to get information to the desired computer. The transport layer, the layer number 4, verifies the effort and hides the network from the layers above. The remaining layers 5, 6, 7 treat the data as if it was local. Okay. First, physical layer. We will discuss a little bit detail. Not that detail, but yes, little bit about the layers. Okay, first layer is the name of the first layer is physical layers. There is no interpretation at this level. A stream of ones and zeros are put into a form convenient for transmission, a form that make it easy for transmit. Wave with little regard of their information content are sent and received. The signal are sent and received in this layer. This level is the most hardware oriented. It includes specification about NIC card speeds. NIC we have discussed before. Network interface card, network interface controller or card. Speeds, okay. Second is types and length of the cable. Okay, you can see the cable, the card, all those physical hardware. Okay, relate dengan hardware. Third is hardware characteristic, voltage characteristic in terms of range, voltage level, and also voltage age, and for etc. Some other details of the hardware or the physical. That is what happened in physical layer, first layer of OSI modules. The physical layer involve protocols for actual transmission, which relate to, first is Ethernet, second is FDDI, third is RS-232, and fourth is ATM. So what is Ethernet? Okay, Ethernet is the internet lah. Ethernet is a family of wired computer, which normally it is related to LAN 1. Okay, Ethernet is a family of wired computer networking commonly used in local area network or metropolitan area network or wide area network. That is Ethernet. Okay, what is FDDI? FDDI is Fiber Distributed Data Interface. It's a standard for data transmission in a local area network. It uses optical fiber as its standard underlying physical medium. So FDDI is related to fiber optic network. Okay, Fiber Distributed Data Interface. For copper, they call it CDDI, Copper Distributed Data Interface. Okay. Third is RS-232. RS-232 is this is the connector, type of connector. Maybe you have seen before. Okay, RS-232 is recommended standard 232. It is a standard originally introduced in 1960s for serial communication transmission of data. So RS-232 is related to serial data transmission. Number 4 is ATM, which is stand for asynchronous transfer mode. ATM is asynchronous transfer mode is a telecommunication standard defined by ANSI and ITU-T for digital transmission of multiple types of traffic, including telephone, data, and video signal in one network. Okay, so that is briefly about ATM. These protocols also involve the interface with the next higher layer, the second layer. Okay. Second layer, the data link layer. At this layer, one begins to consider bytes instead of just bits. one examines some of the information content of the signal, at least the address and some of the error detection sequencing. Recall that bridge operate at this level. So at the data link layer, bridge operate at this data link layer. So the bridge know where a packet is headed. They know whether or not it has been involved in a collision or not. And also bit stuffing. Bit stuffing, we will discuss about bit stuffing a little bit after this. Also occurs in this level, in this layer. So data link layer, data packets are encoded and decoded into bits. So data packets are encoded and decoded into bits. It directs packets and handles errors from the physical layer. It handles synchronization, also known as timing. Okay, so timing is related to synchronization. It must know where one bit ends and the next one begins, and it must know where one byte ends and the next one begins. So you have bits and you have bytes. Okay, so we will see the difference between bit and byte. There are two sublayers in data link layer. So in data link layer, there are two sublayers. The data link layer is divided into two sublayers. So two sublayers. The first one is MAC, the second is LLC. The MAC, which stands for Media Access Control sublayer, takes the signal from or puts the signal onto the transmission line, touches the physical layer. So this is the one that's called MAC or Media Access Control. The LLC, Logical Link Control sublayer, starts to interpret the signal as data, includes timing or synchronization and error checking. So LLC, Logical Link Control, involve synchronization and error checking, while MAC, Media Access Control, involve transmission line. Take and put the signal onto the transmission line. Layer number 3 is the network layer. Network layer. In this layer, we can find a router. Okay, the router at this layer. One of the main functions of the layer is routing. Okay, store and forward are network layer function. Routing sometimes relate to store and forward. Save, store and forward. In store and forward function in the third layer, which is called network layer. In a connection oriented scheme, the virtual circuit is established at the network layer. So it is related to connection. In a connection oriented scheme, the virtual circuit is established at this layer, network layer. Building the routing tables, troubleshooting the routing tables when there is a lot of traffic or if a connection goes down. The network layer also gathers related packets, okay, which relate to packet sequencing. So that is about the network layer. Number 4 is layer number 4 is the transport layer. Okay, the transport layer, number 4. As stated before, layer 4 is the dividing line between the inter-computer transaction and intra-computer transaction. So we have discussed before that the layer number 4, which is transport layer, is known as the dividing line or the border. Okay, dividing line or the border between intercomputer transaction, the inside the computer transaction, and intra-computer transaction, outside the computer transaction. Layer 4 manages end-to-end verification. The lower layer makes a best effort, but if data is lost, so be it. Layer 4 must make sure that the information was received intact. It does a higher order error checking. So in transport layer also have error checking. The transfer should be transparent. The higher layers do not know the data came from another computer. Okay, that is the transport layer. Whose job is it? At note, layer 3 collects associated packets. If one was dropped, it may throw them all away. It is the responsibility of the sources layer 4 to look for some acknowledgement that all packets have arrived. If no acknowledgement is received, so it should be retransmit. The data should be retransmit. Okay, layer 5. Layer 5 known as the session layer. Recall when discussing connection-oriented scheme, we mentioned that the idea of a session. Okay. It is an agreement between a source and destination to communicate. This layer, the session layer, layer number 5, establish, manage, and terminates session between application. They could be on the same computer or on different computers. So that is the session layer. Layer 6, the presentation layer. This layer provides independence from differences in data representation, for example, in encryption, by translating from application to network format and so on and so forth, vice versa. The presentation layer works to transform data into the form that the application layer can accept. This layer formats and encrypts data to be sent across the network, providing freedom from compatibility problems. It is sometimes called syntax layer. So presentation layer sometimes called syntax layer. That is the 6th layer. The 6th layer. The last layer is known as the application layer. This layer supports applications and end user process. Communication partners are identified, quality of service is identified, user authentication and privacy are considered, and any constraints on data syntax are identified. So these are the description for the 7th layer, which is the application layer. Everything at this layer is application specific. This layer provides application service for file transfer, email, and other network software services. Telnet and FTP are applications that exist entirely in this 7th layer, which is the application layer. These are not applications like Word and Excel, but services for such application. Okay, so that is the discussion about the 7 layers of OSI principles, OSI model. So basically we have discussed in detail all those 7 layers. So that's all for this video. Thank you for your attention. Okay, we will meet again in another video. That's all. Until then, thank you. Bye bye.